Okay, so last time we were talking about the Pythagorean theorem. This time we're going to talk about the converse of the Pythagorean theorem. Pretty easy stuff. So, anyhow, pretty easy stuff. Don't think you'll find this stuff too complicated. So, let's go. So, our objective today, students will be able to use the converse of the Pythagorean theorem to determine if a triangle is indeed a right triangle. But this converse has more value than that. You could actually determine whether you have an acute triangle or an obtuse triangle. So we will be learning a new idea shortly here. Second question we want to think about: how can you use the sides of a triangle to determine if it is a right triangle? That's our central question, it looks like. Well, let's find out. So here's a triangle fact. One of the facts that you should know, just kind of in your bag of tricks and bag of knowledge, The sum of any two sides of a triangle must be larger than the third side. Otherwise, it's not a triangle. What you talking about, Mr. Russell? Okay, so I thought I'd give you a picture of this. Let me get my pen going. What would you say is the shortest distance between 2 points? It's the straight line, right? Or the straight path, right? That would be the shortest distance, right? Shortest? Right? I mean, if this is like 20, and let's say I'm taking a straight path here, if I take any other path, wouldn't it be longer than that? You sure? like if I decided to go this way and then this way, wouldn't that be a longer path? You see? So this is kind of what this is saying. If you take a look here, the sum of any two sides of a triangle must be bigger than the third side. Like if I did this here, that might be 16 and that might be 8. 16 and 8 must be bigger than 20. And if you look at this side, if you add these two sides, it must be bigger than that one. And vice versa. These two must be bigger than 16. So that happens on any triangle. It's called the triangle inequality theorem or whatever. Excuse me? Oh. Okay, I thought I heard an interesting question, but... What about equilateral? All right, hang on just a moment. I'm being called. Okay, so that's what this triangle fact is about. Any two sides of a triangle must be larger than the third side. All right, that's a little trick or idea we should remember from here on out. Okay, let's move on. Okay, so I did that little distance. Okay, the converse now. There's three scenarios that can come up when you use the Pythagorean theorem. You can get, what am I talking about here? Let's look at this. You see, when we have a triangle, you can have a right triangle, an acute triangle, or an obtuse triangle. And when you try this Pythagorean theorem idea, like a squared plus b squared, if it turns out that you have some triangle that you're not sure about, like let's say I have this triangle here, and I know I've taken and I've found the lengths of them. Like I maybe found out that this one's 7 and this one's 8, and I may have found out that this one's 16.5. My question might be, is this a right triangle? I know, it maybe looks like it, but I'm not sure. Okay? Well, that's what this converse is about. It tells us if you try the Pythagorean theorem idea, a squared plus b squared equals c squared, and it does equal c squared, then you have a right triangle. If you add a squared and b squared and it's larger than c squared, then you have an acute triangle. And if you have a squared plus b squared and it's smaller than c squared, then you have an obtuse triangle. So those are the three scenarios that can come up, and that's really all this section's about. So it's pretty easy stuff. So let's move on and try a few examples, and I'll let you get going on the study guide and also working on the homework. The study guide's only like 5 or 6 problems, so it'll only take you 20 minutes to do maybe or less. Well, let's try this out. So we're trying to determine whether we have a right triangle or not. And so the longest side is always going to be the c squared. So this one is my c. Now, does it matter which one's a and which one's b on the other two sides? Really doesn't matter. Okay, so I'm going to say a squared plus b squared is equal to c squared. That's the question mark that I have right now. So if I put the numbers in where they belong, I get 9 squared here. I get plus 15 squared is equal to 3 square root 34 squared. Okay, now you can use a calculator to help you in some of these calculations if you don't know the answers off the top of your head. Most of you, I hope, know what 9 squared is, right? 81. This one should have a square on it. Plus, what, 225? Now those are actually pretty easy. But how about this one? This one's not so easy to do. Like I said, you can use a calculator. But what is this saying? When you have the square up there, it's telling you you need to multiply this expression by itself twice. So this is really 3 times the square root of 34 times 3 square root 34. Well, if you multiply a square root by itself, it's always like going to cancel itself out. So the square root of 34 times square root of 34 is actually 34. Okay, that's an idea I learned a long time ago. And then 3 times 3 is 9. And if you do 9 times 34, you're going to get the answer. Let me see. Hang on just a moment. 9 times 34. You get 306. So the question is, here's the question. Oh, my goodness. I'm allergic to math. 306. Is this equal to 306? Or is it less than? Or is it greater than? Well, if I take 81 plus 225, I get 306. Okay, so that answers my question. They are equal. And if they are equal, I got 306 on this side, I get 306 on this side. What does that mean? Well, it means that this is a right triangle. So that triangle there was indeed a right triangle. So you make some sort of statement when you're doing your assignment. You say, therefore. This is the math symbol for therefore. It doesn't mean that you're in a game. Therefore, we have a right triangle. Does that make sense? Everybody good with that? So it's real easy to use this Converse. You just, it's abbreviated, RT, right, left, LT, right, RT. Okay. Well, let's take this triangle. Maybe the same thing will happen. Maybe it won't. I'm going to erase some stuff here so I have some room. Okay. Any guesses? No, is it a right triangle or not? Do you think it is? You don't think it is? It doesn't look like it. Where would the right angle be? I mean, I hope this is kind of obvious, but where would over here? This where top right. I agree. That's where it would be, right there, right? Okay, well let's check it out. We have a squared plus b squared, b squared, and the question is it equal to c squared? Okay, my friend AP, what numbers go where? Which one's the long side? The 26. And where does that 26 go? C part. Yeah, that would have to go in there. So there's a 26 here. And we'd square that, right? And then these other two numbers go in over here, right? Doesn't matter. Right, so I'm going to change colors now. How about if I change to black? Okay, so this would be 22 squared plus 14 squared. Now these, you could easily just calculate in your calculator. 22 squared is, I think, 441. Let's see if I'm right. No, it can't be 441. Let me see. Oh, 484. 484. Plus 14 squared. I think that one's 196. And then 26 squared. That's over 700 or something. 26 is squared. 676. Okay, so if we add these two together, that's 680. Well, as you can see, this is bigger this side than this one. 676. So what's the conclusion? We could say, therefore, it's not a right triangle. Well, what kind of triangle is it then? It's not a left. No. Is it a cube or is it obtuse? I think it's a cube. You see? A cube triangle. Let's go back. If C, now this side was the C squared, right? The C squared is the smaller side, right? This side over here was the A squared and the B squared, right? We were adding those. And the C squared is smaller. So let's go back. Let's go back to our theorem. If the C squared is the smaller, and that's what we have right here, A squared plus B squared is bigger, then we have the acute triangle. There you have it. Jesus was right. Hallelujah, right? Okay, so those are the three scenarios. My friends, you can do the study guide right now, get it done, and then work on the book assignment. We will be ready tomorrow to start 7.3. Doing the study guide and the book assignment today.